OpenFGA meets Envoy, and consequently Istio. Jose Carlos Chavez worked at Okta as a security software engineer, open source lover. So what we have here is crossing paths. OpenFGA is, well, you know what it is, right? A fine-grained access control platform. And the idea is that we can take this fine-grained access control not only to user or user to resource communication or user to service or whatever, but also look beyond that and think of service to service communication or machine to machine communication, right? So what I'm working on is an integration on OpenFGA on Envoy, which is a proxy gateway or a sidecar. You can use Envoy in different environments. So we have crossing paths here. We have Istio, which is a service mesh. Basically, it's an abstraction of the network, which run Envoy as sidecars for workloads like services, for example, gateways, ingress, or whatever. And then they have Envoy working as policy enforcer. So in front of every workload that you deploy in an Istio, you most likely have an Envoy acting as a reverse proxy. Envoy is a proxy or gateway that allows to add filters that calls external services by gRPC or HTTP, right? So then when the request comes, we will see in the next slide, you can call an external service to determine whether this request can continue or not. You send it to upstream or just block it. OpenFGA is authorization solution that builds granular access control, right? And then Aspire, it's a project for identity attestation on workloads, right? Basically, when we have to resolve an access control check, we have a subject, we have an object, right? The subject is easy to get, right? You usually have an API key, you have a JOT, you have a cookie in the session. But the other part, the internal part, is not necessarily easy from the gateway standpoint. So Aspire attempts to resolve all these kind of things by giving identity to workloads, right? Don't want to go deeper into this. How does this work? Well, in the upper graph, you will see that whenever there is an HTTP or gRPC call from the client, it goes to Envoy. Then Envoy will call a gRPC authorization service, right? Saying, hey, this is the request. Headers, path, query parameters. Can this proceed or not? And then the authorization service will, for example, in this case, will contact FGA and ask for the check. And then with that response, Envoy will send this to the service or return back to the client saying 403, for example. And in the deployment, we want every Envoy to, whenever there is, when we are in a service-to-service scenario, what we want is that when two services talk to each other, they have a common, or first they present each other with their own identity, and they say, this is my certificate, this is me, right? And then we have a centralized authority that will issue the certificates, and then you can trust each other, right? And that's why Aspire does the work for this image or identity attestation. So with these two words, what we are looking here is that we can either say, can this user access to this service because I have the identity from the client based on a JOT or based on a cookie session or based on API or whatever. And then in the other hand, we have an identity that I can add to the model through an SPIFFE identity, for example, that says this service is mydomain.com/service A or service B, right? In a way that is trustable. This all in the context of zero trust, right? Where you have to roll out policies as if the attacker was internally. So you cannot anymore trust workload traffic because it could be a man-in-the-middle attack, or it could be that an image is compromised, or imagine that you have the case where a service in tier 1, or a service that is not supposed to be tier 1, is tier 2, let's say, is trying to connect the service in tier 1. That's something suspicious. But as of now, you don't have a way to resolve these decisions. But now, since every workload will have an identity, you will. So let me quickly show a demo. Basically, what I did here is I am running an Envoy. Here is the configuration. Basically, this Envoy will act as a reverse proxy.
We are not seeing your screen.
Sorry.
Slides.
Let me share the other screen. Sorry about that. Okay. We will deploy an Envoy service. This Envoy service will have certain configuration about an external authorization, which is a service that we create specifically for Envoy. You can check the project OpenFGA Envoy. And this service is going to receive a request with a JOT. It will, of course, validate that the JOT is well signed, that the signature is valid, and it will extract the payload, and then it will send to the downstream service so that the downstream service know who is calling this. And then through the Spire agent, it will also know, okay, where is this request going? And then we can do the check. This external authorization service, it has a very simple configuration. Basically, you tell them where is the OpenFGA server, what is the store ID, the mode, whether it is enabled or not, and then the instruction sets. Basically, here we are aiming to extract information from the request about the user or the subject, extract information from the request about the destination or the resource, and also what is the relationship that you're looking at. In here we are, where is this? Here. In here we are looking at we are extracting information from a JOT. Basically, Envoy will send the JOT payload in this header. We will look into that, and we will resolve that as the subject. We will look at the SPIFFE identity of the object, like what service am I querying, and then the relationship will be the request method, right? The model will look like something like that. We have a user, we have a SPIFFE, then we can define the access. Can the user access to this SPIFFE identity, which will represent a workload? And there's certain conditions, right? We can say like, okay, this user can access this object, which is the API, for example, with the allowed methods get, right? And then we see the test that with get, it will work, with delete, it won't work, because we are only allowing get. This is a very simple model, but we could have like different kind of models. For example, in gRPC, the method is basically the method name, right? So we can even go more granular, because when we talk about HTTP, we have the verb, the HTTP verb, and then we have the path. But since the path can have a high cardinality, because it can be, the ID can be anything, we can restrict by get. But if we, for example, follow a REST API approach, then we know that there is a structure, and then we can extract the relationship as /users, for example, / the user ID. Then we can say like, okay, the resource I am trying to access is the user ID that is on the end of the URL, and the type of the resource is users, and then I can build the object or the resource with those conditions. Basically, one of the good things about OpenFGA is that you can model this in different ways. For example, if we talk about an Istio environment, we will have more entities, not only user and SPIFFE identity. We will have namespaces, services, clusters, nodes, and then we can do access decisions based on them. Let me share the terminal quickly. Yeah, so we have, you can see, I have a Docker a Docker Compose instance. We have an Envoy here. We have an OpenFGA service running here. We have an OpenFGA external authorization server, and we have a destination, right? And then we will do a curl just to show. This is going to be the access token that you, after the login, you will get. In this case, I use the test token from Auth0. So I do the export, and then I will do the curl. I will try to access the /headers endpoint. and I will get a headers. It's 200. Okay, because according to my model, I have access to that. But for example, if I do post, I will get a forward tree, right? Because I didn't add a tuple saying that I can access the post. Again, this is a very simple test because we are looking at the HTTP pair, but it could be the path, it could be a specific query, it could be a path prefix, for example, or based on a header or whatever I can extract from the request. What happened underneath was, like, for example, if I look at the Docker logs of this container in the XOZ service, I had different access decisions requests. In this case, the service is in mode enabled, but I can have monitor mode or disable mode. Monitor mode is I check the access decision, but I don't block if it's blocked, right? And then I see checking permissions. This user that I pass in the yacht, is asking for the relationship, is checking the access for the relationship access on the object of this SPIFFE identity. And then it resolves the access granted because it was the get, right? And then the second request was I am extracting values from the request. I'm checking permissions here, again the same, but with the post, and I get the access denied. Again, all this happens because I extract these values from the request. Remember that I did, let me quickly short this so I can, sorry. Remember, I set up a set of extractors on the configuration of this here. Because this is important because I could have different extractors for different conditions. And this is a user to service, let's say, access control. So I have one extractor that checks the user, checks the object in the SPIFFE identity, and checks the relationship. It could be a service to service. So in the user, I will have another type SPIFFE, and then the access control will be service to service, right? And we could have, this is a list, so you can have fallback also. Like, for example, when you are querying from outside, right? You are unauthenticated, so you don't have a payload job, for example, whenever you are first trying to access the login. Then you will have another instruction set just for that case where you're unauthenticated. Or if you're authenticated with a cookie, we will have a cookie extractor that will extract the identity from the cookie. The object will be the same, the SPIFFE identity, and the relationship can be this request method, it could be the path, it could be whatever. Okay? So yeah, what is coming then? Let me quickly show you. What is coming? Well, find granted access on user to resource in a REST API, user to endpoint service namespace, node, cluster, etc. on Kubernetes, service to service, service to namespace, service to node, service to cluster on Istio. This is what we are aiming for on this OpenFGA with Envoy integration. And yeah, I'm giving a talk about this on Monday, a longer talk, more well explained. Yeah, this is it. Thank you.
Thank you very much, Jose. I don't know if you have any questions around this, but if you all are interested in following along with Jose's progress, the code is available on OpenFGA/OpenFGA-Envoy on our GitHub repository or GitHub organization. So keep an eye on that for sure.